Okay, question number 7 is, by first obtaining a quadratic equation is cos of theta, solve this equation and range over this theta is given to you. It should be lying between 0 degrees to 360 degrees. First of all, the hint that is given to you that you have to convert your equation in cos of theta. So this equation should be converted into cos of theta first. You know that tan theta can be written as sin theta by cos theta times by sine of theta, which is equals to 1. Sin theta will gives you sine square of theta by cos of theta, which is equals to 1. Sin theta is equals to cos of theta. It can be written as sine square theta is equals to cos of theta by using cross multiplication. Now use one of the trigonometric formula that relates sin theta and cos theta. That is sine square theta plus cos square theta, which is equals to 1. Subject your equation in sine square of theta, that gives you sine square theta is equals to 1 minus cos square of theta. Plug in this sine square theta value in this equation number 1. So it gives you 1 minus cos square theta is equals to cos of theta. Why I just did that? Because I have to convert my whole of the equation in cos of theta first. That's why I just did that. Now I have to find the factors. I need the values of theta. So I just make a quadratic equation over here so that I can solve it. So it can be written as cos square theta minus cos of theta plus 1, which is equals to 0. Now I have to find this value of this theta. There are three methods through which I can solve this equation: by making a factor, by making a quadratic formula, or by completing square. Making a factor is not possible here because there are two conditions in order to solve this equation by making a factor that are not going to satisfy over here. So I will use you can say quadratic formula over here. In order to apply quadratic formula, I need some assumptions. Assumptions are: put cos of theta is equals to x. Whenever I just put cos of theta is equals to x, my equation will reduce into x square minus x plus 1, which is equals to 0. Now I have to apply quadratic formula here because factorization method is not possible for that. So for quadratic formula, my a value is 1, my b value is minus 1, and c value is also positive 1. Now you have to use quadratic formula here in order to find your answer. Whenever you apply your quadratic formula, I just write down general formula for quadratic equation here, that is theta is equals to minus b plus minus b square minus 4ac dividing by 2a. You have to put all the values in this quadratic formula here to find your answer for this theta. Whenever you plug in your values in this equation, your theta will be coming as 0.618 and the other value is minus 1.618. These are two values for this cos of theta here. This is actually cos of theta. Two values are there, one by the positive and the other one from the negative. Now you have to use some concept for this cos of theta. If you know the oscillation period for cos, like the limiting value for this cos, you know that cos theta gives you the maximum value that is less than equals to positive 1 and less than equals to negative 1. There are two limiting values for this cos of theta, maximum 1 and minimum minus 1. So it will never be equals to negative of minus 7 by 7.18 because its value upper range for this cos of theta is positive 1 and minimum range is negative 1. So negative 1.618 is never choosable because of its restriction. So that's why I have to consider only the positive value for this cos of theta, that is 0.618. So I just choose cos of theta is equals to 0.618. I have to find theta, then definitely I have to do theta is equals to cos inverse of 0.618. Hold your calculator and find your answer. Your theta will be coming as 51 51.8. Cos inverse of 0.618 will be coming as 51.8. Now go back towards your question. You can see the restriction for this theta is 0 to 360. Consider your quadrants. You know that cos theta is always positive in first quadrant and fourth quadrant. Second and third quadrant suggest that cos will be negative here in the second and third quadrant. So cos theta should lie only in these two quadrants because it will be positive here. And my theta is positive, it's positive 51.8, so I have to consider only first and second quadrant. If you remember, in the first quadrant, in order to find the principal value of this angle, theta will remain as it is. And in the fourth quadrant, you have to do pi minus theta. And in the second quadrant, it will be multiplying by minus theta. And in the third quadrant, that would be theta minus pi. I am in the first quadrant, so first quadrant value will remain same, that is 51.8. So that is my first answer. If you go back to the fourth quadrant, I have to do pi minus theta. So pi minus theta suggests that pi value is in maths, in the degree form, pi value seems to be 360. So 360 minus 51.8 degrees actually you have to do, and that seems to be 308. Yeah, 308. So two values for this question will be there. One is 51.8 degrees and the other one is 308 degrees. That is the required answer for this question. Hope so you understand.